Chapter 12, Section 12.1, page 357, Measuring Force. Forces are often easy to measure. In fact, if you've ever shopped at a grocery store, you may have measured forces using a spring scale like the one shown in Figure 2, which is a picture of a grocery store scale. The stretch of the spring in the scale depends on the amount of weight, a type of force, acting on it. As more fruit is placed on the scale, the spring is stretched farther and the scale reading increases. Force is measured in newtons, abbreviated as capital N. 1 newton is the force that causes a 1 kilogram mass to accelerate at a rate of 1 meter per second each second. Or another way to say that is 1 meter per second squared. In fact, 1 newton is equal to 1 kilogram meter per second squared, or 1 equals 1 kilogram times meters per second squared. The newton is named after Sir Isaac Newton, the English scientist who explained how force, mass, and acceleration are related. You'll learn more about forces and mass in the next section. Representing a force. You can use an arrow to represent the direction and strength of a force. The direction of the arrow represents the direction of the force. The length of the arrow represents the strength or magnitude of the force. In Figure 2, which is the shopping store scale, the force arrows represent the weight of the items on the scale. Both arrows point down because weight always acts downward. The lengths of the arrows show you that more weight acts on the scale in Figure 2b than the one in Figure 2a. So Figure 2a has fewer apples in the basket than Figure 2b, and so it's more weight or more downward force in Figure B with more apples. Combining forces. Have you ever helped to push a car that has run out of gas? If you have, you are taking advantage of the fact that forces can be combined. The individual force of each person's push adds with the others into a larger force that allows you to move the car. You can combine force arrows to show the result of how forces combine. That is, forces in the same direction add together, and forces in opposite directions subtract from one another. The net force is the overall force acting on an object after all the forces are combined.